Good morning, all of you. In the last lecture, we have studied the solution of a second order linear differential equation, that is a homogeneous linear differential equation, and differential equation having a different types of solutions. They are going to discuss by using today's lecture, that is cases of a second order linear differential equation. That is, we have to consider the four number of cases. First one is a real and distinct root. Real and distinct root means we have real and unequal roots. Second case is real and equal roots. Third one is a complex pairs, and that is we have to say that complex conjugate roots. And the last one is roots of the type alpha plus or minus root beta. These are the four cases we have to discuss for this article. Now, first of all, we have to consider the real and distinct root. For this, we have to consider the auxiliary equation. We know the auxiliary equation, equation 2, that is called as what? Auxiliary equation. We have to study in the last period, that is d square. What you have to consider? D square plus a1 into d plus a2, that is equals to what? 0. That is f of d is equals to 0. That is called as a quadratic equation that having a solution of the type we have to consider here. The auxiliary equation has a real and distinct root. Auxiliary equation 2. Auxiliary equation has a real and distinct. Auxiliary equation has real and distinct roots. That is m1 and m2 are, that is m1 and m2 are the distinct root. General solution of equation 1 is, auxiliary equation has a real and distinct root, that is m1 and m2. The solution of equation 1 is, equation 1 is what? Second order linear, homogeneous second order linear differential equation, and that having a solution of the type, that is y is equals to, first solution, y is equals to c1 e raised to m1x plus c2 e raised to m2x. This is the solution we have to consider for the second order linear differential equation for the real and distinct roots. Means we have, if the auxiliary equation has a real and distinct root, auxiliary equation has a real and distinct root, that is m1 and m2. The solution of first second order linear differential equation is of the type y is equals to c1 into e raised to m1x plus c2 into e raised to m2x. This is equation number 3. Remember, this is the very important solution for a second order linear differential equation, that is a real and distinct root. m1 and m2 are the real roots, but they are unequal. That's why we have to consider the solution is y is equals to c1 into e raised to m1x plus c2 into e raised to m2x, where c1 and c2 are the another constant. Then second is we have to consider real and equal roots. Case number 2. This is case number 1. Real and equal roots. Second case we have to consider here, real and equal roots. When two roots, that is say auxiliary equation has a two roots, that is we have to consider say m1 and m2, and but they are real and equal, means we have to say that if m1 is equals to what? m2 is equals to say m. Auxiliary equation has real and equal roots, means we have to say that the auxiliary equation are having a equal and complete solution, that is not given by equation number say 3, which is such a situation has only a constant. In order to get the solution of differential equation, auxiliary equation has two equal roots, that is we have to consider m1 is equals to say m2 is equals to say m, and after that we have to consider we write the equation 1 that is what? D minus m, another bracket, D minus m into y is equals to say 0. First root is say m1 and second root is say m2. So the factors we have to consider D minus m1 की जगह replace होगा m, m2 की जगह replace by m. That is D minus m, another bracket D minus m into y is equals to say 0. Let us put here D minus m into y is equals to say v. That is equation number say 4. D minus m into y is equals to say v, equation 4. Then we have to consider here, that is d is considered as what? D is considered as say d by dx, and then we have to get that d by dx minus m into y is equals to say v. Therefore, first of all we have to consider here, that is dy by dx minus my is equals to say v, is equals to say v. We have to consider here sorry. First of all, put this value in equation number say above equation. What is the above equation we have? D minus m into, this factor is considered as what? V is equals to say 0. And therefore, we have to write that d is nothing but d by dx minus m into say v is equals to 0. Therefore, we have to write say dv by dx minus mv is equals to 0. Therefore, dv by dx is equals to say mv. Separate the variable, 1 upon v into dv is equals to m into dx. Integrating, what is the integration we have? Integration of 1 upon x into dx, that is nothing but the log x. That is, we have to say that ln of v, integration of dx is considered as x mx plus what we have to say that c, and then taking exponential, what you have to get that is v is equals to e raised to mx into e raised to say c, but e raised to c is nothing but say capital A. Therefore, v is equals to, we have to consider a into e raised to mx. V is equals to, we have to get that a into e raised to mx, which gives, this is v is nothing but what? A into e raised to mx. Now substitute this value in equation number, what we have to say that say 4, we get, put in equation 4, why we have to substitute this value in equation number 4? We have to get that d minus m into say y is equals to, what is the value of e? That is a into e raised to mx, right? A into e raised to mx. This can be, we have to write that dy by dx minus my is equals to a into e raised to mx. Equation number 5. Equation number 5, which is the first order linear differential equation. And what is the solution of that equation? We have to discuss. Method of solution of this is given, which is discussed in the first order, and that is integrating factor. The method of solution have been discussed. Method have been discussed in first order. Method have been discussed in the first order. Now we have to consider here, that is integrating factor is e raised to minus mx. Hence solution of equation 5 is integrating factor is e raised to minus mx. Integrating factor is, we have to consider e raised to minus mx, and solution of equation 5 is now what is the solution of equation number 5 we have to consider here? That is y into e raised to minus mx is equals to, that is integration of a into e raised to mx into e raised to minus mx into dx. We have to consider here, that is factor is this one, and finally this can be cancelled here, and it gets that y is equals to e raised to minus mx, and that is integration of a into dx. And finally what we have to write, the integration is what? Y into e raised to minus mx into a is the constant, integration of dx is say x, plus constant of integration is say b. B is constant. And finally we have to write that the equation is y is equals to ax plus b into e raised to plus mx, and this is the equation we have to consider, that is the solution, equation number say 6, right? Y is equals to say ax plus b into e raised to mx. This is equation number say 6 number equation. See, two cases are very important here. The first one is what? Real and distinct. That is solution of the type is what? Y is equals to c1 e raised to m1x plus c2 e raised to m2x. This is the first solution when the roots are unequal. If two roots are equal, at that time we have to consider the case is what? m1 is equals to m2 is equals to say m. We have to write the equation of the type, solution of the auxiliary equation of the type is what? D minus m. We have to find the quadratic equation having the two roots x minus 2 and another is say x minus 3, another bracket. Like that we have to consider d minus m is the first bracket and d minus m is another bracket into y is equals to say 0. Substitute here d minus m into y is equals to say v. Equation number 4. Put this value in above equation. Equation becomes d minus m into v is equals to 0. D is nothing but d by dx minus m into v is equals to 0. Solve this equation. dv by dx minus mv is equals to 0. Here minus it gets plus, dv by dx is equals to say mv, and separate the variable. Variable separate करा, v चे एका बाजूला, dx चे दुसऱ्या बाजूला, 1 upon v into dv is equals to m into say dx. Integrating both sides. What is the integration? We know the We know the formula, that is integration of what? Integration of 1 upon x into dx is nothing but what? That is log x. Log x. And integration of dx is nothing but what? X. We have to use this formula for the integration of that. That is ln of v into mx, plus we have to write the constant of integration is say c, and taking exponential, logarithm is going on. V is equals to e raised to mx into e raised to c. Finally, e raised to c is equals to say a. Substitute here. The solution of the type is v is equals to a into e raised to mx. Substitute in equation number 4. We have to get that d minus m into y is equals to a into e raised to mx. A into e raised to mx, and dy by dx minus my is equals to a into e raised to mx, which is the first order differential equation. And the solution of this method of the solving solution of this equation we have to consider in the last lecture. So we have to consider the integrating factor is e raised to minus mx, and solution of equation 5 is becomes y into e raised to minus mx. We have to multiply this side e raised to mx also, that side e raised to mx. Integrating factor is there, that gets cancelled. The remaining factor is this one, y into e raised to mx into integration of a into dx. Finally it gets that y into e raised to minus mx, a into integration of dx is nothing but x, constant of integration is say b, and finally y e raised to minus mx is multiplied, here divide, it gets the positive, that is y is equals to x plus b into e raised to mx. This is the solution of that equation. Write down these all things, very important. These solutions are very important. All the terms are very important. Write down all these terms clearly.